Hello friends, welcome to Multiverse YouTube channel. It is a one-stop solution for Gate ESE, SSC JE, for AE, JE, PSU exams, and for college-going students who are preparing for semester exams also. In the previous class, we have discussed internally reversible cycle Internally reversible cycle means no irreversibility within the system. No irreversibility means no loss in the system or within the boundary of the system, we call it. And we discussed what is externally reversible cycle. Here, externally reversible cycle means no irreversibility outside the system. Okay. Now moving further, today we will be discussing on totally reversible cycle. Here, totally reversible cycle means the summation of internally reversible cycle and externally reversible cycle means a process which is internally reversible as well as externally reversible is known as totally reversible cycle. When these both are combined and we call it as totally reversible cycle means no irreversibility in the universe. Okay. Suppose if I discuss this totally reversible cycle on a graph, Suppose this is the pressure axis and this is the volume axis. Suppose system undergoes a process from state 1 to 2. Okay. If in irreversible process it is basically a quasi-static process, means infinitely slow process. In infinitely slow process, the system undergoes a many equilibrium states. From one, the system is undergoing some equilibrium states from 1 to 2. Okay. As it is internally reversible cycle, means I will be showing with a bold line. Do you get it? Or solid lines. If I want to go back via same equilibrium state from 2 to 1, it will be an internally reversible process only, but it is not mandatory that we have to go via this path only. But for the time being, I will be going from 2 to 1 via this path only. Okay. Now, as I discussed for the internally reversible process, if in externally reversible process state of the surrounding is changing, no irreversibility in the surrounding. Okay, so I can write it as a process of system is totally reversible if the system and all parts of its surrounding can be exactly restored to their respective initial states after the process has taken place. From 1 to 2, I am going, process is taking place, and from 2 to 1, uh, another process is taking place via same path. It is not mandatory to go within the same path, but I am going from the same path only. This process is known as totally reversible process. Okay, the, we have to come to the initial state, that is the totally reversible process. Now moving further, irreversible process. Here, irreversible process means the process which is not totally reversible. Where the system can be of three processes, there is some irreversibility or over the universe. Here the three processes are, as I told you, that irreversible process means not totally reversible process, where system can go three processes, that is internally irreversible process plus externally reversible, the other is internally reversible plus externally irreversible process, and the third one is internally irreversible process plus externally irreversible process. If in these three cases any one process is taking place, then the process is irreversible process. Okay, now irreversibilities are present within the system or in its surrounding or both, is known as irreversible process. Okay, if system undergoes either internally reversible process or externally irreversible process, or both are taking place, then it will be a irreversible process. I can write it as in an irreversible process, if the system undergoes either internally irreversible process or externally irreversible process, or both, is known as irreversible process. And I can write it as in an irreversible process, irreversibilities are either present within the system or in its surrounding, or both. Means if the irreversibilities are there in the system or the surrounding or the universe, then it will be irreversible process. Okay, here there are some causes of irreversibilities. The causes of irreversibilities are, as I told you, that in internally reversible and externally reversible process, that heat transfer through finite temperature difference will be an irreversible process. I explained you in externally reversible process, if you remember. Means there is loss in the surrounding. This is one of the cause of irreversibilities. Heat transfer through finite temperature difference. And friction also. Second point is friction. If once the friction is taking place, there will be some loss of heat which can't be come to initial state after losing the heat when friction is taking place. And third one is free expansion. Fourth one is free expansion. Suppose for a small example, I'm taking a box one of the half is filled with a gas, and this is the vacuum. When you are rupturing this membrane, the gas will redistribute. This is known as free expansion. This gas will redistribute into the other chamber also. As we can't take it to the initial state. This is an example of free expansion. And the fourth example is plastic deformation. Plastic deformation in the sense, in strength of materials, we will be studying on the up to elastic zone only, but in material science it will be subjected to, some of the materials will be subjected to plastic deformation. Okay, which can't be regained to the same initial state. Fifth one is hysteresis. Losses. When the core is subjected to magnetization, which you have been studied in +2. Okay, and this is the common example, mixing of gases. When you mix some one or one, two, or three gases, which it can't be regained to the same initial state. These are the causes of irreversibilities. Okay. Now the next topic is cyclic process. Here cyclic process means, suppose you are driving a bike. When you are driving a bike, the bike engine will have a continuous cycle. It works on a continuous cycle. Suction, expansion, suction, compression, expansion, and exhaust. Like that we have uh, like that is the only cyclic process. That is an example of cyclic process. Okay. If a system undergoes number of processes such that initial and final states are same. As I gave you the example of engine, suction, compression, expansion, exhaust, again the cycle starts with suction, compression, expansion, and exhaust. Means the initial is the suction, again the final is the exhaust, again you are coming to initial state suction, and the final state is exhaust. Like the cycle continues. This is only known as the cyclic process. Means it should have a continuous effect. Whether it is a power producing cycle or power consuming cycle. Power producing cycle means the IC engines, and power consuming cycle means refrigerator. All this comes in the power consuming cycle. Refrigerator, AC, you can write it. If I show you the this cyclic process in a graph, it will be much clear to you guys. Suppose this is x-axis and this is y-axis, and the process is taking place from state 1 to state 2. From state 1 to 2, I am going via a path A. Okay, here I am taking all the processes as externally reversible process. This is the hidden assumption. Again, to complete the cycle, I am going from final state to initial state via path B from 2 to 1. Okay. Here 1 A 2 B 1 is a two process reversible process. Again, for more clarity, I am this is the x-axis and this is the y-axis. Suppose a process is taking place in three processes. From state, it's a three cycle process. From it's going from 1 to 2 to 3 via a path A, and this path is B, and this path is C. Here, as I told you, that the initial and final states are same, and similarly here also the initial and final states are same. What I can conclude here is 1 A 2 B 3 C 1 is a three process reversible cyclic process. The hidden assumption is externally reversible process. Now moving further, again a process is taking place suppose this is the x-axis and this is the y-axis. from 1 to 2 a process is taking place, and 2 to 3 via path a process is taking place, and 2 to 3 another process is taking place, and 3 to 4 a process is taking place, and 4 to 1 a process is taking place. Let it I will be drawing like this for accuracy purpose. Okay, what I can conclude here is here the cycle 1 A 2 B 3 C 4 D 1 is a 4 process irreversible cyclic process. 1 to 2 process is taking place, but from 1 to 2 the cycle is irreversible process, so the whole cycle will be a 4 process irreversible cyclic process. Okay, now moving further, characteristics of properties. Suppose I am taking a pressure volume axis as process is taking place from 1 to 2. This is the volume axis, which will be in meter cube, and this is the pressure axis, which will be in bar. Suppose this is 2 bar, and here I am taking a 10 bar, and the volume is 2 meter cube, and the final volume is 10 meter cube. A process is taking place from 1 to 2. For the first process, the volume is 2 meter cube, and pressure is 10 bar. The first state is 2 meter cube and 10 bar pressure, and a process is taking place from 1 to 2. The volume is 10 meter cube and pressure is 2 bar via path A. Here I have drawn with solid lines or bold lines. I can say is 1A2 is a internally reversible process, and I am taking another process which is taking place from again 1 to 2 via path B. Here 1B2 is internally irreversible process. If I do calculation for the process 1A2, the change in volume will be 10 minus 2 4 8 meter cube. This is for irreversible internally reversible process. If I do the calculation for the path 1B2, the change in volume will be the same as 8 meter cube, and this process is for internally irreversible process. Here what I am trying to tell is that whether the path is 1A2 internally reversible process, whether the path 1B2 internally irreversible process, the property, the value which I am getting is the same. What I am trying to conclude here is property are independent of the path followed. If you take in the case of change in pressure also, you will be getting the same results. You can calculate separately. What I am trying to tell, please understand here, the property are independent of the path followed, whether depending on the state. Okay, means here the property are known as state function. Whether the change in volume is same only. Okay. Here I am moving from one point to one point. The state is moving from one point to another point. So what I can conclude is that properties are also known as point function. Okay, whether the change in volume and change in property are same from 1 to 2, not depending on the path. What I am trying to conclude here is property is an exact differential. I can write it as a process is taking place okay, doesn't matter whatever the path is. Here D is the exact differential. Property are exact differentials. Okay, now a cyclic process is taking place from 2 to 1 via path C, means a reversible cyclic process. Here what you can observe is that when the cyclic process, as I told you that initial and final states are same, means it is a reversible cyclic process. For the path 1A 2C1, a reversible cyclic process is taking place. Okay, for this path, I am calculating the change in volume 1A2C1. The change in volume is 2 minus 2 is 0 meter cube. Here 2 is the initial state and here another 2 is the final state. Again I am calculating the change in volume for the path 1B2C1. The change in volume will uh, here it is a irreversible cyclic process. The change in volume will be for the path 1B2C1 is 0 only. Final state is 2 and the initial state is 1. Sorry, in final you will be mind. Sorry, guys, here is small. You will be taking the difference of final state to initial state. Which is 0 meter cube. Here what you can observe is the change in volume for the cycle is 0. What I am trying to conclude is for a cyclic process, change in property is always 0. For a cyclic process, change in property is always 0. Okay, here there are some few points to be noticed. As I told you that uh, mm, whatever the path, whether internally reversible or internally irreversible process, the difference of properties between two states is exactly same, hence properties are known as exact differentials. I can write it also has in differential form properties are represented by dv. Okay guys, let's conclude this class. Please share to your friends, like it, like the session, share the session so that it can be reached to so many mechanical engineering students who are preparing for these exams. And please subscribe it and comment how the classes are going on, how I am teaching. Please let me know whether I have to improve the class or not. Okay, for PDF, please join Multiverse exams.